Alright, AP. Um, Sorry I couldn't be with you guys today. I will be with you guys again soon. This lesson video, however, will go just like we do in class. So if you guys can please have that Google Doc open, the one with the forms. We are reviewing AP Classroom video 7.3 and 7.4 today, which involves slope fields and finding solutions to differential equations. So this is 7.2 Form A. Okay, so in that Google Doc, this is page 27 out of 28, and of course you have the little menu on the left side. So if you guys can just open that, hit 7.3, 7.4, and it takes you to these forms. Okay. Number 1 says construct a slope field for the differential equation. Okay, so slope fields, okay, ain't too bad, thankfully. And what's happening is you're using the differential equation that's here, and you're just going to be plugging in values, x and y values, based on the plane that they give you. Okay, and as you plug them in, whatever that slope is, you basically sketch the little line. That's all there is to it. Okay, so for this one, you want to do it for every possible point. So I actually overdrew my plane a bit. Okay, they actually, if you look at the form, they're only giving -1, 1, +1, +2, and then -1 for the y's here. Okay, but here's the differential equation. Okay, let's take the origin first. At the origin, okay, this is an x value of 0 and a y value of 0. So you would plug in 0, 0, and then compute all that, and of course you get 0. So at the origin, you have a slope field of, or a slope of 0, I should say. So my red will be my slope lines. Okay, so this is the slope at the origin of whatever the graph of this differential equation is. Okay, so then right here for +1, now you have 1 comma x value is 0 here, right? The y value is 1 at this point. So then you're going to be plugging in 0 and 1 for the x and y respectively, right, at this point here. So x value is 0, y value is 1. X is 0, that goes away. Y value is 1, 2 times 1 is 2. So then right here, this graph, whatever it is, it has a slope of 2. Okay, again, 0 plus 2 times 1, you're going to get 2. So I drew in a slope line of approximately 2. Okay, now right here, this point, that's a y value of 2, but x is still 0, right? You're still along the y axis here, so the x value is 0. So 0 comma 2. Now when you plug that in, you get 0, and then 2 times 2, that's 4, right? So 4 is a steeper slope than this one right here. I got 2 here. Okay, so you want to make sure, okay, that you are accurately representing your slopes. Okay, so this one's a slope of 4, this one's a slope of 2. Okay, so I need to make sure that that's clearly visible, right? It's steeper. So actually, hang on, I think I can pause this. Okay, I think it should be okay when we're recording, but sorry, the puppy had gotten something she wasn't supposed to. Anyway, so now you move on here, right? Or you can, I mean, really go across any point you want. So we're going to take now along the x-axis. The x value here is 1, the y value is 0, right? So again, right here the x value is 1, the y value is 0. So 1 plus 2 times 0, you get 1. So this one here would be a slope of 1. Okay? So again, that one here was a slope of 2. You want to make sure that one's steeper or appears steeper than this one right here. Okay? So let's go with now this one here. This is -1. So -1, okay, plus 2 times 0, right? Because the y value is 0. So -1 plus 0, you get a slope of -1. So this was now a negative slope. So make sure you draw a negative slope. Okay. So there it is. Okay, let's go down here. This is a y value of -1. 2 times negative 1. 2 times negative 1, that's going to be negative 2, right? That's negative 2, x value 0. So you get a slope of negative 2. So that's about this slope here, but just negative. Okay, it looks about the same, hopefully. Now, let's plug in, right, this point here. This point right here is positive 1 for x, negative 1 for y. So you're going to plug this in. Okay, so positive 1 for x, negative 1 for y. That's going to be 1 plus negative 2, or 1 minus 2, and I get negative 1. Okay, so slope of negative 1 is approximately like that. Okay. Okay, next, let's go up here. This is x value 1, y value positive 1. So 1 plus 2 times 1, that's going to be 1 plus 2, which is 3. So 3, you're going to want it to be definitely steeper than this one, right? Because it is steeper slope. Hopefully not quite like the one I have up there. That one is a slope of 4, right? And then now you want to plug in this one up here, which is an x value of 1 and a y value of 2. That's going to be 2 times 2, 4, and then this is 1, so 5. To make it even steeper, a slope of 5. Okay, so we're just going to keep going now on this side here. Okay, and let's go with this one down here then. Negative 1 and a slope of, sorry, x value negative 1, y value of negative 1. This will be 2 times negative 1 is negative 2. Negative 1 plus negative 2, that's negative 3. So then I'll have maybe about something like this. Right, I think this one was a slope of 3. I forget. I think this one was it. So about the same, just negative. Then you want to go here. Okay, an x value of negative 1 and 1. And that would give me positive 1. So positive 1 up here. Okay, and then finally up here, an x value of negative 1 and a y value of 2. So 2 times 2, that's 4, right? And then x value negative 1, you get positive 3. So that should be this exact slope right there. And boom, there you go. Okay. This one will represent, again, the slope of whatever equation this differential one represents. So if you take the integral, for example, of this here, you'll find yourself getting an implicit equation. Actually, I think you'll get 1/2 x squared plus y squared is equal to then the constant, and what that will be will, I think that's a, if you guys remember, that's a conic section. So okay, another thing you should know about slope fields is, for example, if we had a rational equation, right, and you were plugging in, say, an x or a y where your denominator was 0, right, there would be no slope there. It'd be undefined. So then on the slope field, you would have missing slopes for whatever values you're plugging in for x and y, which would indicate an asymptote. Okay, it represents a function with an asymptote. Okay, this one here says find the general solution for the differential equation. Forgot to mention this at the beginning, but please pause the video to write in the problem, and then of course resume once you've written it. This one, find the general solution for the differential equation. What you want to do here is, okay, you want to just quickly set an expression, okay, that will enable you to integrate and find that original function. Okay, so dy dx, the differential equation, is 1 over x minus 3. If I multiply both sides by dx, I'm going to get dy is equal to 1 over x minus 3 dx. Right? Then what I can do is I can integrate both sides and have this right here. Okay? So if I do this to both sides, now I can integrate, okay, the integral of dy, which is by, okay, y is equal to the integral of 1 over x minus 3. Use the unit 6 reference sheet that I posted some time ago. Okay, what that's going to do is that'll be equal to the natural log of the absolute value of x minus 3 plus c. Okay, this is the equation that will represent that differential equation. Now for number 3, it says find the particular solution of the differential equation, and I got 7x minus 3y y prime is equal to 0. That satisfies the initial condition of, and I have this right here, f of 3 is equal to 5. Write the answer in standard form. That's the standard form of equation there, right? So what you want to do is take that differential equation. I'm just going to rewrite it first. And I'm going to send the y's over to one side and keep my x's on one side as well. So if I add 3y y prime to both sides, I'll get this. 3y y prime to both sides. Okay. Y prime, I can say that, right? Same thing. And so then if I integrate both sides, then I got this. Okay? And so then on this side, if I integrate 7x, what that's going to do is, let's see, I'm going to get, right, add 1 to the exponent, divide by that new exponent. That's 7 over 2 x squared. And right here, 3y, whoops, equals to 3y dy. If I integrate with respect to y here, add 1 to the exponent, divide by that new exponent, I'm going to get 3 over 2 y squared dy plus c. Okay, so it's almost in that form that they want our answer in, right? Except I don't know what c is. Okay, but did they give us that initial condition, right? That says right here, that satisfies the initial condition that f of 3 is equal to 5, right? So 3 comma 5, right? When x is 3, the y value is 5. So that's my x and that's my y. Okay, so I'm going to very quickly here just subtract both sides by 3 halves y squared, because that equals to c. Right, all I did was subtract this term here back to the left side, right, so that it starts to take this form on the left side. Okay, and then now what you want to do is just plug in that x and that y. So 3 right here, if I plug in 3, I'm going to get 3 squared, that's 9. 9 times 7, 63, so 63 over 2. Okay, 63 over 2. If I plug in 5 right here, 5 squared, that's 25. 25 times 3, that's 75 over 2. Okay, so 63 over 2 minus 75 over 2, that's equal to c. Okay, 63 over 2 minus 75 over 2, that's going to be negative 12 over 2, which simplifies to c being negative 6. Okay, so 7 over 2 x squared minus 3 over 2 y squared is equal to negative 6. The very last step you want to do is you want to get rid of your fractions. Okay, so just multiply everything across by what's going to help you eliminate these fractions. And if you multiply by 2, right, 2 0 cancel, 2 0 cancel, and then you'll get negative 12. So then the final answer will be 7x squared minus 3y squared is equal to negative 12. Okay? Please reach out if you guys have any questions. Alright, so now we're going to do Form C to further reinforce these skills here. Okay, and by all means, pause the video again and maybe even try them on your own first, right? And then watch the video and see if you were able to get it down. Okay, so for this one here, let's start with the origin. At the origin, you have 0, 0. So 0, 0, you get 0. So slope of 0 here. Okay, here I have an x value of 1, a y value of 0. So 2 plus 0, right? 2 times 1 is 2 plus 0. Just get 2. So that slope will be something like that. Okay, let's go with this one here now. X value of 1, y value of 1. So 1, 2 times 1 is 2, plus 1 you get 3. So an even steeper one. Okay, and then up here you have x value of 1, y value of 2. So that's going to give me 2 plus 2, which is 4. So even steeper. Okay, and then keep going, fill in, right? I think at this point you guys should understand what's happening. X value of 0, y value of 1. So that's 0, 1. You get a slope of 1. Okay, there's a slope of 1. And then right here, x value of 0, y value of 2. So you just get 2. So steeper. Right here, this is x value 1, y value of negative 1. So 2 minus 1, that's 1. So there it is. Right here, x value 0, y value negative 1, you get negative 1. So that's that slope. Here, that's negative 1 for the x and the y. So negative 2 minus 1, you get negative 3. So negative slope, like that. Right there, y value of 0, but x value of negative 1. So 2 times negative 1, that's negative 2 plus 0, so negative 2. So steeper. Okay, and then finally right here I got an x value of negative 1, y value of 1. So negative 2 plus 1, I get negative 1. So about there. Okay, and then right here I get let me see, x value of negative 1, y value of 2, negative 2 plus 2, I get, would that be 0? Let me see, negative 1, that's negative 2, yes, and then 2, yeah, you get 0. So then flat slope there. Okay, alright, again, if you had a rational function equation, right, something over something, and you were plugging in, and let's say you did get 0 in the denominator, that indicates, right, that slope wouldn't exist, right? And so then the case there would be you have some form of asymptote happening in the graph. Okay, alright, this was to find the general solution for the differential equation. We have dy over dx of 1 over x plus 2, so very similar to the one we did. Okay, so what you want to do is multiply both sides by the dx so that you get this set up here. Okay, this will allow you now to integrate. Okay, the integral of dy would just be y. The integral here, again, use the Unit 6 reference sheet. This stuff is there. Okay, and you'll get ln absolute value of x plus 2 plus c. That would be the general solution there. Okay. Finally, it says find the particular solution of the differential equation, and we have 8x minus 2y y prime is equal to 0. That satisfies the initial condition and we have this. X value -2, Y value would be 3. Write your answer in standard form. So again, what you want to do is you want to move your y's over to the right side, keep your x's on the left side. So you'll get 8x is equal to, this is -2y, y prime, so if I send it over to the right side, I'll get positive 2y. And I'm going to change y prime to dy already. Okay, and I have this. This will allow me now to set up the integrals. Okay, if I integrate this left side, add 1 to the exponent, right, I get 2, divide by that new exponent, 8 over 2. I get 4x squared, and that's equal to, right here, add 1 to the exponent, divide by that new exponent, the 2's will cancel, so I get y squared plus c. Okay, so now I have to solve for c. I'm going to start setting it up like standard form. So I'm going to move the y squared back to the left side. That'll give me 4x squared minus y squared is equal to c. Okay? So again, when f is -2, so when the x value is -2, my y value is 3. So if I plug this in right here, -2 squared is positive 4. 4 times 4, I get 16. And then right here, y value is 3, right? So minus 3 squared, I get 9. So 16 minus 9 is 7. So that's C. C is going to have to be 7, right? I might have skipped a step there. I forgot to write the C. Anyway, so C is 7. This time I don't have those fractions, right? So once I plug it in, it's already in that form. A is 4, B is 1, C is 7. Or B is -1 actually, but anyway. Okay, and that's it. Okay, this reviews the stuff that was covered in AP Classroom Video 7.3, 7.4. Okay, on Wednesday we will be reviewing sections, I believe it's 7.6 and 7.7. Okay, 7.5 is skipped. 7.5 is not part of the AB curriculum. It's actually part of BC. Okay, so if you were wondering, wait a minute, what happened to 7.5? Okay, again, it's not part of the curriculum here. Section 7.6 and 7.7. Okay, and we will review those on Wednesday. Don't forget to submit your notes, okay, and grades will still be updated tomorrow, Tuesday, so have your stuff in, okay? Bye, guys.